Okay, again, thank you so much, and hope everybody is well and doing okay in these difficult times. The good news in the Netherlands, actually, we are just about to come out of a lockdown, and things are getting easier, probably at the end of this month. So it's maybe that Omicron is saving all of us. That's our hope, at least now in the Netherlands. Yeah, the topic of today of this seminar is early life stressors and life course health, with a specific focus on collaborative projects in the European Union, like Bert already mentioned. This work starts with David Barker. David Barker is an epidemiologist who passed away, I think now 7 years ago, a British epidemiologist and the founding father of the developmental origins of health and diseases. He says actually this hypothesis that an adverse fetal or childhood environment during specific critical periods of life leads to permanent changes in organ structure and function may have detrimental effects on health in later life. So a lot of circumstances in the earliest phases of life may have long-term consequences. This is also the basis of a new, actually a new shift towards prevention into the earliest phase of life. This early phase of life, let's say the preconception, fetal life, and early infancy, are periods of high plasticity. And whereas this period is, of course, a vulnerable period and a critical period for development, it's also a window of opportunity for new intervention strategies to try to get people, future generations, into better life course health trajectories. And the concept of David Barker is not only his concept. You probably will know that the James Heckman Foundation, or specifically James Heckman, stated that the best investment for the future is probably the investment in the earliest phase of life. So prenatal programs, early childhood programs, both in education but also in health, may have long-term consequences for society at its broadest sense. And the early life stressors in the title. Yeah, what is early life stress? Early life stress is actually everything what is in the earliest phase of life, a potential stressor for developmental processes. I like to call the earliest phase of life preconception, pregnancy, and early childhood, which roughly is the first 1,000 days of life. And of course, it's very broad. It may have to deal with the society in a broader sense, the cultural background of individuals, of course, living environment, neighborhoods, the kindergarten, schools, the closer environment like friends, but also lifestyle diet and physical activity, and of course also the genetic susceptibility of an individual. This all leads to healthy weight trajectories or health trajectories in a broader sense. And I like to focus very much in this presentation on obesity as a major exposure, but also as a childhood outcome, as an example how we address this in this European cohort network. Why do I focus on maternal obesity as an early life stressor? Early life, exposure to maternal obesity in the earliest phase of life does have specific consequences. It exposes the fetus and also the child to specific nutrients, which may reflect the nutritional states of the mother, of course, also, but may have specific metabolic effects in the fetus and also in the child period. To better explain this, what is obesity and what is gestational weight gain in relation to both pregnancy, but also in relation to the exposure for the fetus? So clearly, obesity is one of the markers for maternal nutritional status. It reflects some transfer of nutrients to the fetus. These are important for developmental processes, but it's also, in the case of obesity, a factor related to insulin resistance, to high glucose transfer, but also fatty acids disturbances. Gestational weight gain is a very complex exposure. Of course, every pregnant woman will gain in weight. That's normal. And what is gestational weight gain? It reflects tissue expansion, fluids, fat storage, but it's also, of course, related to growth of the fetus, the uterus, and the placenta. And according to the IOM criteria, the Institute of Medicine, almost 40% of the full population in Western countries currently does have increased rates of weight gain, so actually too much weight gain. I will come back on this. And of course, it's very clear that obesity clusters in families, so also in mothers and their children. We know already that gestational weight gain is a complex exposure, but also it's related to various social background characteristics like lower educational level, In our case, non-Dutch background. So in the Netherlands, we have a lot of ethnic minority groups, different ethnic minority groups, an unhealthy lifestyle. It's related to insulin resistance and high glucose concentrations, to disturbances in fatty acids profile, but also to disturbance of the cardiovascular profile in pregnancy, including preeclampsia and diabetes, gestational diabetes risks. And we know from classical retrospective cohort studies, especially in the UK, this was a register-based studies, that maternal obesity, actually before pregnancy already, leads to a higher risk of earlier mortality. You see it in this curve, in the survival curve. You can see the brown curve with obese children from obese women do have a lower survival rate as compared to those from underweight or normal weight women. Of course, the question in these kind of studies always, is it biology, is it programming, or is it really confounding? That becomes not clear from these kind of studies. In the Generation R study, we do a lot of studies on specifically the effects of maternal obesity and gestational weight gain on childhood outcomes. We do it first in our own cohort, the more detailed studies, but I will also in this presentation or in discussion present the EU Child Cohort Network and illustrate what we can do in this kind of broader, bigger collaborations between a lot of cohorts. And I will close with some future perspectives for research. The Generation R study, it's our, what we call our, in our department, flagship study. It's a prospective cohort study now started 20 years ago, almost, actually by Bert Hoffman. Follows pregnant women from the earliest pregnancy period, so from early fetal life onwards. Generation R is not the biggest cohort around, but it's very specifically focused on detailed measurements in a larger group. And a large group is 10,000 pregnant women, partners, and their children. It's a multi-ethnic population in the city of Rotterdam, the Netherlands, which is the second city in the Netherlands. And actually, what's most important in this cohort study that we have in Rotterdam, in the Generation R study, is this prenatal phase. This is the golden basis of this study, and also the backbone of a lot of studies which are still ongoing. So the pregnancy and fetal period. We did a lot of ultrasound measurements, which is also the trigger for most women to participate, physical examinations, cardiovascular measurements, questionnaires, but also DNA, blood, and urine samples. And after this very detailed measurements, we follow up these children at 6, 10, 13, and nowadays 17 years. For this presentation, I will focus on these specific outcomes, which is growth, cardiometabolic measures. You can see the body mass index, body fat measured by DEXA scanning, abdominal fat measures by ultrasound, detailed cardiac and vascular measurements, metabolomics, the renal outcomes, and also, of course, DNA, or actually GWAS or EWAS measurements in maternal and childhood blood samples. More specifically, we have a Generation R specific MRI, which actually is used for each time, for each age window, 5, 10, 30, 70 years, to perform a total body MRI, including the cardiovascular system and liver fat, pericardial fat, and visceral fat. I will come back on this. So what we started with is just to look at the associations of maternal weight categories, underweight, overweight, obesity. You can see it on the x-axis in this figure, in these figures, and the risk on childhood obesity in the first figure, and second on the clustering of cardiovascular risk factors, let's say metabolic syndrome markers. And you can see almost a linear association. The reference group is normal weight. It's not depicted in this picture. And you can also see that for those women who have excessive gestational weight gain, so more than what is expected based on their pre-pregnancy BMI, according to the IOM criteria, they also have an increased risk of both childhood obesity and the clustering of metabolic risk factors. But these risks are lower than obesity itself. And the question when you see this is, of course, what is this? Is this causality? Is it confounding? Is there any biology involved? And there's different approaches how we address that in these kind of cohort studies. I will show you some results from our study, but also from others. First, from another study, which is already an older study, 2006. There's also a follow-up in 2009 of this study, which actually is based on a sibling comparison. a sibling comparison study by comparing siblings both before bariatric surgery of women, of obese women, but also after. You can see that children born after bariatric surgery have a much better cardiometabolic profile from 2 to 18 years as compared to the siblings who were born before the bariatric surgery. Of course, there are all kinds of limitations in these studies. Of course, these women are not totally comparable, but at least it gives some clue that if you improve the metabolic status of these women by the bariatric surgery and also their weight, it may have consequences for the offspring. A second approach, which we use a lot in our study, is the Mendelian randomization, which is based on the genetic variants related to the exposure of interest, so in this case, BMI, and are by definition not affected by confounding. You can use them as instrumental variables, so as proxy exposure for the real exposure. And what we do observe is the genetically elevated maternal BMI, so the genetic risk score, which is based on BMI, is also associated with offspring birth weight. So it suggests that at least the association with maternal BMI and offspring birth rate is causally, it's a causal association. The associations of these genetic risk factors with childhood cardiovascular outcomes are not consistent. It may have to do with power because we were underpowered in our study, but it's also not consistent if you look at studies from a similar size. So I think there's much more needed there. Another potential study approach which helps to identify confounding or causality is to compare the effect estimates for fathers and mothers. And of course, if you really think this is an association which is explained by uterine program mechanisms rather than a broader lifestyle socially related exposure effect, you would think that the effects of the mother are stronger than the effect estimates of the father. That's actually what we observe in our study, and this is also not always consistent for all studies. It also has to deal with power because you need to disentangle the effect estimates for mother and father. But at least this gives some clues that the effect estimates for mothers are stronger than for fathers when we look at childhood outcomes. So taking this further, we were specifically interested if you look at the programming effects of maternal obesity or gestational weight gain in relation to childhood outcomes, obesity, cardiovascular outcomes, what is the specific critical period? Because if it is causal, you may also try to identify critical periods which give some kind of opportunities for development of preventive strategies. And here you can see maybe a little bit complex figure, but I will explain it. You can see 4 age periods on the x-axis: pre-pregnancy, early pregnancy, mid-pregnancy, and late pregnancy. This graph actually shows the association between weight in these specific periods in relation to the outcomes which are on the bottom of the slide, on the left part of the slide, in the red box: body mass index, fat mass index, subcutaneous fat, all DEXA scanning, but also visceral fat, pericardial fat, and liver fat measured by MRI. And you can see that actually only the weight in early pregnancy and pre-pregnancy were associated with these outcomes. And you can also see that the strongest effect estimates were observed for pre-pregnancy. These analyses are based on a conditional regression modeling, so the weight measurements are adjusted for each other in this period, in this graph. So these results suggest actually that if there's any association, you should look at the pre-pregnancy weight and early pregnancy weight. And why do we study pericardial fat and liver fat? Because, of course, BMI, body fat, that's clear. But pericardial fat is really interesting. Pericardial fat, as we know, especially for the Framingham Heart Study, it's strongly related to coronary heart disease, also mortality, but also to metabolic syndrome. Actually, we do not find that strong associations of pericardial fat at this age range of children aged 10 years, 6 to 10 years, with cardiovascular risk profiles. But for fatty liver, it's different. We do, of course, perform MRI studies for assessing the liver fat steatosis, or fatty liver disease. It's a category, it's a definition. And please realize that non-alcoholic fatty liver disease is the most common liver disease in childhood. Of course, due to obesity, it leads to inflammation at the end, to failure or cirrhosis. And what we did find is, of course, that maternal weight before pregnancy, early in pregnancy, was associated with a higher liver fat. But we do also see that this liver fat fraction in a full range, but also if you dichotomize this, is associated with clustering of cardiometabolic risk factors. This is interesting. Of course, you can say that liver fat is also part of the metabolic syndrome. That's certainly the case. But at least we show that here in this figure, that liver fat fraction or liver fat in childhood is not that innocent. It may already be related to an adverse cardiovascular risk profile. So that's why we included also as an outcome for the maternal weight and obesity, obesity and gestational weight gain studies. So these were the studies that we performed in Generation R before we thought, okay, if we want to go further, if we want to may have some impact on public health level or population level, what is needed? And of course, we really need to try to identify at least what is gestational weight gain? Is it relevant? So what are the ranges? Can we define optimum gestational weight gain ranges? Because realize in clinical practice, at least in a lot of European countries, a lot of weight measures are performed during the gestation. In the Netherlands, at least 12 or 13. And whereas there are some advices are given, nothing is actually evidence-based. So we really try to identify what are the ranges for both just observational weight gain, but also for optimum weight gain. Is it related to long-term outcomes, and what are the potential mechanisms? And we established the Life Cycle Project, which is actually a project focused on early life stresses and life cycle health. It's a typical Horizon 2020 project, the bigger European research programs funded by the European Union. Actually, the aims of Life Cycle is first to bring together pregnancy and child cohort studies throughout Europe in a new open and sustainable EU child cohort network. And please realize this is a similar model as the ECHO consortium from the NIH in the US. So actually we started, I think, a little bit at the same time. We want to use this network to establish this network, but also to use this network for identification of novel markers of early life stressors. So are the new biomarkers, new, in our example, weight gain, trajectories, proxies, can you use that for prediction modeling, for example, but also, of course, translate findings into policy recommendations or prevention strategies. The EU Child Cohort Network, it's a network of, it's about, it differs per analysis, but in the basis of about 28 cohorts throughout Europe. You can see here a map of Europe, and actually the blue dots are actually the cohorts forming the basis of the network, and the reds are actually now joining us. So we have now already a network of 28 cohorts with 220,000 mothers, actually also the fathers and children, so trios. These are not actually only European cohorts, but also cohorts in the UK's not always European. You may be aware of that. But also US, for example, Project FIFA is also joining us, not for all analyses, but for some. And we have Australian cohorts like the RAIN study also involved. You can see it on the picture. We have a follow-up. These are cohorts which started actually from 1990 onwards. Actually, that's starting period of the ELSPAC, which is some kind of the mother of the European pregnancy and birth cohorts. And after that period, especially because of David's Parker hypothesis, a lot of new cohorts start throughout Europe. And the power of this approach is actually, we think it's not needed to always start new cohorts, but it's much more important to enable researchers better use of existing data and existing cohorts, and to try to link these data together and enabling multi cohort analyses. And what we did, I very like to present this because this is important. I think also an example how we can come together as a research group in a time period where data exchange and all kind of difficult legislation is not making things always easier, is what we did. First, we started with an inventory. So what is already available in this European cohorts, primarily European. Of course, based on the research questions we had, mainly the early origins of non-communicable diseases, we identified the core or the target variables. This was a list of about 100 variables. I think we are now about 300 variables already. But some kind of variables that are always needed, like socioeconomic position, ethnic background, smoking, alcohol consumption in this early stages of life, clearly, body weight, but also more detailed mental health trajectories, respiratory function or lung function, but also blood pressure. So a lot of different variables related to the presence of non-communicable diseases in later life. We harmonize these data. So throughout Europe, there's a big effort in the last 3 years for harmonizing this list of data, which took us about 3 years. So a lot of workshops, harmonization protocol changes. We developed a data dictionary visible in a catalog, and you upload the data on specific servers in your own institution. So you do not send, actually nobody did send the data to each other. You just keep the data in your own server, the Opal servers. And of course was a quality control process part of this. This is just an example. This is also open. The website is here. So if you're interested in this network, in the data, in how we constructed this, it's actually, most of the information is just easily available through our website. You can click very easily on each variable, and then you can see a whole list of other variables on that, under that umbrella of the child, the mother, the father, and etc. One of the unique features of this network, and that's a difference as compared to the ECHO consortium, that it's based on a federated structure. So in Europe, we have a general data protection regulation, which says actually that you need a really explicit consent from research participant or cohort participants to send the data to another institution. It becomes even more difficult if you send data, if you want to send data to non-European countries like the US or Canada. Then there's a whole other problem or challenge. So, but even within Europe, it's really much more difficult as compared to, let's say, 10 years ago, to send data to each other. So that's why we developed a federated approach, which has actually, you can see it on the picture, but each institution has its own data on its own server. As you can see, 6 servers, let's say these are 6 institutions. And from each institution, you can just have access to all other servers, of course, with the consent of the data manager of that institution. So the data comes not to the researcher, but the researcher comes to the data. That's actually the principle. So there's no need for sending each other data by email or versus an USB stick or whatever. And by this approach, you can very simply perform individual participant data analyses and you share the summary statistics. You can also not change the data. You cannot add something to the data. The data is only being handled by the own data manager, but at least you can use the data from these different cohorts. That brings me back to the story of this presentation, maternal obesity, gestational weight, and childhood outcomes. So we use this approach of these different cohorts for first developing gestational weight gain charts. And clearly you can imagine if you want to do this for different BMI categories. For normal weight, we can simply do it in the Generation R study based on 10,000 subjects. But if you want to look at underweight, especially obesity grade 2, obesity grade 3, and these are of course becoming more prevalent now in the US, but also in Europe, you really need more numbers. And that's why we combined all these data. And you can very simply here, that's not so interesting from an epidemiological point of view, etiological point of view, but you can see at least the power of these data. What we did create a reference chart for these different obesity categories, including obesity grade 2 and 3, so BMI higher than 40. What we also created is a weight gain chart app. So you can very simply, by having access to our website, enter some information of the woman, which not, it's very easy. So only the pregnancy day, the current day, the weight at the starting point, her height, and you can see whether the weight, the current weight during gestation is between the normal ranges. That's actually the basis, and this is what we used also for the etiological studies. And one interesting finding is, of course, we looked at the association of maternal BMI in relation to childhood BMI in the full range of BMI, because in our own study we only had BMI until 30, 32. So let's say stage category 1 obesity. But if you look at all these data from different cohorts, you can do a much broader analysis. And what you can see in this picture is that the association of maternal body mass index on the x-axis with the standard deviation score of childhood BMI on the y-axis becomes stronger if children grow older. So you see early childhood, dark blue line, mid childhood, the red line, and late childhood, the light blue line. The effect estimate becomes stronger. We know that also from the cohort-specific studies, and actually it's prevalent across the full range of maternal BMI, which is also important. So if you look at maternal BMI as target for preventive strategies, it's not important to only focus on obesity, but probably on changing the whole spectrum of maternal BMI. And of course, last we tried to identify the optimum weight gain ranges. So can we identify the optimum gestational weight gain ranges by having all these data together? And what you can see here is a heat map of, if you look at the red one, the blue one is only the numbers. So where are the highest numbers? You can see it very clearly, the gestational weight gain of 14 and the BMI of about 22. But if you look at the heat map, you can see the number of complications, adverse maternal and infant outcomes, in relation to gestational weight gain, but also pre-pregnancy BMI. You can see a dark red box actually in both corners, very clearly in the upper right corner. So a higher BMI and also a higher gestational weight gain is clearly associated with higher frequency of maternal and infant outcomes. But there's also a tendency for some kind of J shape. So it's only also at the lower ends, you can see some darker red blocks. And what we did with these data is we tried to identify the optimum weight gain ranges. And actually that worked quite well. What you can see here is the weight gain ranges on the right part of the slide for underweight, normal weight, overweight, obesity grade 1, 2, and 3. For the IOM criteria, which is called in classical Dutch out here, but that's the IOM, sorry about that. And you can see here also what life cycle generated. And actually they are a little bit similar. You can see similar range. There's actually a big compliment for the IOM criteria because it was not totally data driven. So actually with our data, we strongly supported the IOM criteria, although there are small changes, especially for the higher ranges of obesity grade 1, 2, and 3. Although the numbers for obesity grade 3 are still low in this sample of 180,000 subjects. And I have to say that, of course, I did not show that. We also tried to predict the infant outcomes based on gestational weight gain, but that was not successful. So gestational weight gain can maybe be used for counseling for during pregnancy, of course, but we couldn't find sufficient evidence to use gestational weight gain as kind of prediction factor for adverse outcomes. Another power of the collaboration between cohorts is, of course, the omics study. I think you will all know the big GWAS study, or maybe also the EWAS study. And what we did in the same collaboration, which is also linked to the BASE consortium, but also life cycle, we did try to identify DNA methylation changes in response to maternal BMI or obesity related to also childhood metabolism or childhood cardiovascular programming. With 19 studies, a little bit less than 10,000 subjects, we identified 86 CPGs in neonatal blood, cord blood, related to BMI, which was, to be honest, a little bit disappointing. We would expect much more. Smoking is leads to much more CPGs, also folate. So it's probably not such a strong exposure for DNA methylation, but we did identify some CPGs linked to genes related to childhood metabolism. And we could also see that most CPGs, or differential DNA methylation in these CPGs, persisted from birth until the age of 18 years. So it was a persistent change in DNA methylation. So what we could say from this is that from both studies in our Generation R first cohort, but also in the EU Child Cohort Network, there are associations from maternal pregnancy, obesity with childhood outcomes. And the strongest associations are for pre-pregnancy and for early pregnancy, BMI. But the developmental mechanisms underlying these associations are not clearly known. And that's actually why we focus now on this very early pregnancy period. And then we come back to our own study, the Generation R Next study, a new study, because we did see this first set of observations in the Generation R study, then we extended it to the EU Child Cohort Network. But if you want to have more detail, more specific research questions, of course, you have to go to your own more detailed study. And we know that early pregnancy is a critical period, not only for maternal obesity, because we know from embryology, all organs are developed in the first, let's say, 13 weeks of life, so in the first trimester. You start with these 2 cells, but at the end of first trimester, you can see a full body with brains, with arms, with legs, with an abdomen, with a thorax, with the beginning of a heart and lungs. So almost all organs are already there. So a lot of things are happening. And what we try to do is to bridge the gap between these rare congenital disorders, but also the less rare common variation resulting from developmental disorders in this stage of life. And why we focus on obesity in this case is that actually we know from our studies that I just showed you that preconception and these early pregnancy periods are really important. It's also acknowledged by the WHO report, the ECHO report from WHO, published 2 years ago. And that's what we do address in Generation R Next. A new study, not repetition of our first study, not only doing the same things and the same kind of association, but something new. So we include in this study women and also the partners before pregnancy. So preconceptionally started study, we focus on embryonic development. So what are the potential developmental effects of maternal obesity, insulin resistance, metabolic disorders related to obesity, but also the set of risk factors related to maternal obesity in relation to embryonic development. I will come back on this. And we want to translate this into population interventions. It's all part of the Generation R Next program. So I just give you some clues. I don't have results yet. We are just finishing the first stage. And we are now working on the cleaning of the data, how this works in these cohort studies. Population-based studies from preconception. It's less big. It's almost 4,000 women and men. It will be around 4,000. Yeah, the corona impact's also here because we estimated 5,000, but we had to stop a couple of months in Rotterdam. We have very detailed measurements in preconception, in early pregnancy and in childhood. And we focus specifically on this preconception health, but also obesity, embryonic development, and the childhood outcomes. And just as an illustration, what you can see here is, and that is the very important specific value of very detailed cohort studies next to the bigger set of harmonized data in the EU Child Cohort Network, is we collect data for embryonic development. So we do collect ultrasounds, we perform ultrasounds at 6, 9, and 11 to 13 weeks. You can see here an embryo of about 9 weeks, and you can see all body parts already present. And what we can do is we can go in a 3D way through this embryo and measure all kinds of organs. So the brain size, corpus callosum, the heart size or volume, the thorax. The lungs are not, of course, open yet, but also the liver. So we just measure everything we can measure, especially from a developmental perspective, to have a very good picture of this development period. And this is actually the picture that also participants get from us, a 3D embryo picture, which is also, of course, the reason to participate for most pregnant women, because in no way you can otherwise get these kind of pictures in the first trimester of pregnancy. And here you can see, here you have an idea about how we do this. It's not clear on a 2D, but maybe you have some clues by seeing this picture. You can see the lung regions, the cardiac regions. You can estimate it by going through this embryo to look very detailed in the borders of these organs. But in a similar way, you can also go to the brains, to the liver, to the kidneys. And of course, this is only size. I have to be clear about it. But it's already much more than we have now, because now we have in our first cohort, for example, only MRI measurements at age 9 for the liver. And now you can see in the critical period of life already see developmental adaptations and related to the exposure, in this case, obesity or weight gain of interest. So I hope to come back on this later, probably a year or whatever, and tell you more about this. This brings me actually already to my last slide. So early life stresses and life course health. Just as a summary, what I really wanted to stress out is the power of cohort studies, and especially the collaboration between these cohort studies. So there's always some kind of drive or idea to start new cohort studies. And I think, of course, that's logical, that's also needed. But please make sure that you are in the right way using existing data. And the EU Child Cohort Network is one approach for that, but also the ECHO consortium in the US from the NIH, from Matt Gilman, is also an example of that, which is also based on existing cohorts with some extensions, similar as the EU Child Cohort Network. Because there's a lot of data and a lot of potential to capitalize in a better way on the data of these cohorts. And for the obesity story, I hope to make clear that obesity is a transgenerational problem. So that's all, of course, also what you see on the streets. If you look around you in Europe or in the US, you can see families with clustering of obesity. But these pre-pregnancy and early pregnancy periods might be important life stressors, but also targets for new preventive strategies focused on the earliest phase of life to help new generations on a better healthy weight trajectories. And of course, if you look into the future, and that's especially our idea also, we're now developing an intervention program, population-based in the city of Rotterdam, to try to optimize weight, pre-pregnancy weight in women with who want to become pregnant or may become pregnant, because we think that's the most critical period of life for weight. And also it's a great window of opportunity because these women are very motivated to have a healthy child. Of course, the results are not there yet. I want to close by thanking you for listening, for attending this seminar, but also for my colleagues. Of course, I used a lot of different structures in this presentation. So first of all, my colleagues from Generation R study, but the title is the EU Child Cohort Network. So that's why I use this picture. Are my colleagues in a time period that we could still come together. This is already 2 years ago, more than 2 years ago in Bristol. And you can see a lot of collaborators from 20 partners having a nice dinner. And this is, of course, at the end of the dinner, looking at the faces. Thank you so much. I hope there's time for questions.